Welcome back to the channel. Today we are going to be learning about subnetting. The concept of subnetting is something in networking and in network security that for some can be kind of an overwhelming thing. I'm hoping that this video will alleviate some of the stress and actually demonstrate that subnetting can be pretty easy. So on your screen right now you can see that we have an IP address 192.168.1.0. When we see an IP address like this, what does it mean? Let's dive into the first piece and let's split apart this IP address into something that makes sense. Our IP address here, we have something called network space, and we've got something that's also called the host space. Now these are two important terms to understand because they have different jobs. The network space is referring to the part of the IP address that is specific to that network. All the machines on the network are going to have that same set of numbers. Our host space is going to be having a unique number that every machine on that network is going to be given. So to drive that home, we've got ourselves a simple network here. And you can see that inside of this private network, we've got ourselves a router and we've got IP addresses for each machine. We've got something unique happening is that 192.168.1, the next machine has a 192.168.1, the next machine has a 192.168.1, and that's good. That shows us that all the machines on this network have the same network space. Let's take a look at the difference here though. We've got a 192.168.2, and over here we've got a 3, and we've got a 4. These are unique identifiers for the individual machines that are going to be on this network. But before we get to that, we actually need to talk about two important things. They are the reserved IP addresses. What is a network address and a broadcast address? It means that these are reserved and that an individual machine cannot have a network address given to it. An individual machine cannot have a broadcast address attached to it. In that network that we just looked at, let's take a look at the network address and the broadcast address of that particular network. So here we are, we have a 192.168.1.0/24. Okay, we'll get into it. What does the /24 mean? And then we have a 192.168.1.255/24. Okay, these two addresses in this particular network cannot be given to an individual machine. The network address is an address that refers to itself. When we look at the 192.168.1.0/24, it's literally like a representation of that network itself. And we can have a variety of different numbers in here to symbolize that this is the network. So it makes sense that an individual machine can't be given the IP address that is symbolic for the entire network. Then we have a broadcast address, and this one has a special job in the network. When we use the broadcast address, we are literally broadcasting traffic to the entire network. So how do we talk to everybody on the network? Well, we need to be able to talk to the network for one, but then we also need to be having a IP address that will allow that kind of relationship to occur. And in this particular network, this 192.168.1.0/24, the broadcast address is ending in a 1.255. I know it might be confusing, like how did we get to 255 here? Don't worry, we're gonna get there, but I want you to remember that we've got two special reserved addresses because this is important when we get to determining how many hosts we can actually have in a network. Let's look at, for example, an IP address. I've got on the screen here a 192.168.1.5, and underneath we've got 8 dashes for each spot that we've got a number. So now in an IPv4 IP address, it is 32 bits. And so if we were to count all of these up, 8, 16, 24, 32, that would comprise all 32 bits of an IPv4 IP address. Now, inside of each of these things, which we call octets, somehow we have to get the representation of 168, of a 1 and a 5 to be in each of these 8 bits. And now I've alluded to what we're going to be doing here in a moment, where we're going to be counting and adding in binary. So computers, they work with binary, ones and zeros. When data is transferred across a network, we have to look at the binary that is being transferred. Let's take a look at how do we calculate the number 5. We've zoomed into the number 5 here, and we've got 8 spots where the 8 bits are going to be using numbers. Now, what's unique in this particular case is that each one of these spots represents a value. Okay? While we can only do ones and zeros in each of these spots for our number 5 in our octet, wherever we see a 1 or a 0, it is actually going to represent the value that is underneath. So let's look at the 1 here. So we go up exponentially. We go 1, 2, 4, 8, 16, 32, 64, and 128. That's 8 spots counting up. Remember, this is binary. So if I want the number 5 here, I'm not going to put a 1 over in the 128. That doesn't make any sense. I'm trying to get to 5. 64 doesn't make sense. 32, no. 16, 8. 4 fits into 5. So I'm going to put a 1 there. And that leaves just 1 left. Because I want to get to 5. So if I have 4 and 2, that would equal 6. That's too many. So we have 4 and 1 make a 5. So in our octet, when we're trying to get to this value of 5, we have 0, 0, 0, 0, 0, 1, 0, 1. Let's go to our next number in our IP address. Now, we're going to follow the same process here. The number trying to get to is 1. So let's look at the binary of this. 1 is way smaller than 128. So 0, 0, 0, 0, 0, 0, 0, 1. That's it. This is all of the binary that we need for our number that we're trying to get in this particular octet. Let's jump over to 168. The numbers are going to change just a little bit here. Using the exact same process here, 168, we have 128 is going to fit into that. Right? That makes sense. 168 is a big number. 128 is a little smaller than that number. So let's use our numbers here to get to 168. 128 is 40 less. So we can quickly go over and see that 32 plus 8 is 40. These 3 numbers would calculate to be 168. So we have 1, 0, 1, 0, 1, 0, 0, 0. Let's go to 192. We're following the exact same process here, folks. 192, let's look at the binary. 128 plus 64 equals 192. We don't need any other numbers because we've satisfied this value that we're trying to get to. And now we've got our IP address that we wanted, and we've got all of the binary underneath of it. But the question here is, how many machines can be in this network? And it all comes down to the concept of subnetting, and that's what you're here for. Let's take a look at the concept of a subnet mask. Now, when traffic is going across the network, how does a machine know that the packet from machine A belongs to a machine B? Are they even in the same network? Well, that's what the network space is for. And that's what the host space is for. So remember when I showed you the /24? You see on the screen we've got a red line, and I've got it going all the way from the top to the bottom. And I've got the binary for our IP address. I've also got bolded on the screen here an 8, 16, and a 24. Okay, this is literally 8 bits over, another 8 bits over makes 16, another 8 makes 24. And we're saying that everything over here is network. Everything over here is host space. With that knowledge, take a look at the bottom of your screen when we have a 255, 255, 255, and then finally a 0. This is what a subnet mask looks like. All of the bits are turned on. 1, 1, 1, 1, 1, 1, 1, 1, 1. All of those numbers added up will equal 255. Let's look at the next octet. 255, 255, and then over here, it's a 0. So your machine is literally going to be looking at this and saying, okay, what is the subnet mask? Which part of the IP address is network space? That's what the subnet mask is doing for us. It's telling us that 192.168.1 is the network space. This is really important. This is the crux of subnetting. Previously, I talked about how these numbers exponentially grow. Let's look at how many numbers we've got. We have 8 spots, 1, 2, 3 through 8. And if I look at 2 to the power of 8, we have the value of 256. Similar and very close to the 255. If we take our total number of host space here, where it's 2 to the power of 8, we get 256. But remember, we have to minus the broadcast address and the network address, which gives us 254. Depending on how big this host space is, that determines how many machines we can have in this network. We have our red line again here, where it's going down and it's crossing over that 24-bit spot. Okay, and remember, everything over here is network, everything over here is host. We have 8 bits that are allowed. So here's our subnet mask, all zeros, and on the left side, all network. That's the mask. It's telling us that this is host space. We look at our network address, 192.168.1.0. 0 is easy binary because it just means nothing is turned on. And then we look at our binary for our broadcast address. We have 192.168.1. And then because we are broadcasting, and we saw previously there was 255, we know that if it's a 255, that must mean that every single bit in that octet is turned on. Let's look at a couple other IP addresses here. This one's really important because this tells us the range of the hosts that we can have inside of our network. Let's look at the first address that we can have. 192.168.1, that's the network, and the first address is going to be 1. Okay, remember we have values for each of these spots in the octet. So if the very first one is 1, then only the 1 over here is going to be turned on. Nothing else needs to be turned on. The last address is 192.168.1, same network space, and then we have everything turned on, almost, except for the last bit, which is a 0. If this last bit here was turned on, it would be the broadcast. So we can't give out the broadcast address. It has to be reserved. So let's just bump 1 down lower than broadcast, giving us the last bit being taken off, so being 254. So in this network, we have host available 1 through 254. I want to take another look at our network space and host space, and I've got a generic IP address network on the screen here, XX. It doesn't really matter, because what I want to show you is that when we look at the CIDR here, and if you're curious what CIDR stands for, it's an acronym for classless interdomain routing. It's essentially saying like that /24, which part of the 32 bits is the network space. That's what I'd like to know. Right now we're looking at a /24. Look at where the red line is. Let's jump down one. Now we're at /23, and we can see that the line is literally moving. Let's go down to 22, 21, and let's go jump down all the way to 16. Now this one's an interesting one. Look at how the network space and the host space are equal to each other. There is a tremendous amount of hosts that can be on a /16 network. Now let's look at another CIDR of 30. As you can imagine, this host space being so small, there is a very small amount of hosts that can be in this network. Now if a subnet can be in any range, and that CIDR can be a 24, 17, a 30, how do we calculate and make it easy? So like at 8, a 16, and a 24 slash, a /8, a /16, and a /24, they're pretty easy subnets to create. But we know that this is not going to be the case all the time. Networks come in all kinds of sizes. How do I figure out how many hosts are in that kind of network? Let's take, for example, a network of /21. This network here, we can see that the /24 here, and we've got our subnet is going to be a /21. We also know that if it was a /24, we would count up and do exponential growth up to that 8th bit, 2 to the power 8. We've got that, 256 minus broadcast minus network address gives us 254. Now here's the part that makes sense, is that we just keep adding numbers. And the math stays the same. Look, we've got 2 to the power of 11 equals 2048. Get rid of the broadcast, get rid of the network address, that gives us 2046. This is how many machines can be on a /21 network. We are going to go through a couple examples here just to drive home the message. And the technique that I'm showing you here is actually quite literally the technique that I do when I'm doing subnetting. I'm a very visual person, so I actually draw out my binary, and I will actually draw a line down where that subnet should be. If it's a /24, put the line there. If it's a /16, put it there. If it's, in this case, a /23, that's where the line is going to be. I've got an IP address of 192.168.64/23, and then 64. That's my IP address for the machine. What we're going to do here is we're going to look at this IP address and figure out the mask, figure out the network, figure out the broadcast, and then figure out the range of this network. Pretty straightforward. Let's go to the mask. So because it's on this side, we know that everything on this side is going to be turned on. Those bits are turned to 1. So this first octet is solidly on this side. Turn it to 1. 1. This is on this side. Turn it to 1. Everything on this side, this is where things get unique, is turned to 1. However, this is a subnet mask, so everything on the right side is going to be 0. Now look where the line falls. It falls right on 23. So that means that this first bit is going to be 0. And then the rest of it's going to be 0 as well. Now if all the bits are turned on, that makes it equal to 255. But in this particular octet, the last bit is turned off, which means it's 255 minus 1, giving us a total of 254. Great! This is the subnet mask for a /23 here, 255.255.254.0. So then what's the network spot? Let's go down to our next one here. 192 matches our IP address up there, 168.64, and it still has the slash there, that's fine, but it's going to have a 0. So that's an easy one, 192.168.64.0. The broadcast. And I like this about this example because if you were to see this without knowing where the slash is, things can get a little screwy and a little confusing. Let's look at it. Look at the binary specifically over here. 192.168, easy. But now compare this to our broadcast to our network. Is that 64 was the network, and over here 65 is our broadcast. That's weird. Let's take a look. In a broadcast, all of these have to be turned on. So that means that even this spot right here, it has to be a 1. It has to be turned on. So if we took it our 64 here and we add the 1 there, it totals 65. 192.168.65.255 is our broadcast. Let's go look at our smallest number. So this would be the first address. We know that this is the network space, so 192.168.64.1. We look at the binary, we know that if it's going to be a 1, the first one, it has to be set to 1. The very last one is 192.168.65, because remember, we're turning all of these on, except for the very last one, because we don't want to use the broadcast. So that gives us 254. And this one's going to throw you just a touch, okay? And up until this point, I haven't talked about classes. I've only been using 192.168, and that is a class C. But what we're looking at here is a class A. And so this would be just another kind of private network. Okay? It's not super important right now, because right now we're just talking about subnetting. But let's talk about subnetting in a private network that looks like this. So we know that when we have our binary, we're going to add these together. So 1, 2, 4, 8. So that makes 0, 0, 0, 0, 1, 0, 1, 0. This value up here, 10. And it's 10, 10, so let's duplicate it. So we got the same binary. And our IP address is 0.100. So 0, that's an easy octet to add up. And 100 is going to be the binary that you can see on the top of the screen here. All of these values added up will equal 100. Okay, let's go down to our mask. All of the first octet is turned on, the second octet turned on, the first bit here inside of our third octet is going to be turned on, but then everything else turned off. Now let's do the math here. Pretty easy, there's only one bit to work with here. And we know that this spot right here, this first one here, its value is 128. So if that bit is turned on, then that means that that octet is 128. Beautiful. So for a /17, our mask is going to be 255.255.128.0. Our network is going to be ending in a 0, so we have a 10, 10, 0, 0. Our broadcast gets interesting, and we have 10, 10, and remember it's a /17 here at the bottom of the screen. All of the bits on the right side of the screen are going to be turned on, but because we can't change anything in the network space, this stays at 0. And so if we take 128 out of 255, that leaves us with 127, which makes it for an interesting broadcast address, 10, 10, 127, 255. Let's take a peek at the first address and the last address, and you're noticing a trend here. Quote, 10, 10, 0, 1, that's our first address, and our last address is 10, 10, 127. Remember, everything's turned on except for the last bit, which is going to be 254. So that is our last available address in this particular /17 network. I hope you enjoyed this video. Subnetting doesn't have to be scary. I've got some other videos on the screen that can help you with learning, and we'll talk to you soon. Have a great one. Bye.